Hello, hello everyone. Welcome back to the channel. So today we will be taking a look at this question called the flowers, which is a very nice problem for from the Atcoder DP contest. So let's take a look. So I will definitely recommend you to pause the video and try the problem on your own. And if you are not able to come up with the solution, yes, here we go. So there are n flowers arranged in a row for each I 1 less than or equal to I less than or equal to n. The height and the beauty of the ith flower is given. So Taro is pulling out some flowers so that the following condition is met. The heights of the remaining flowers are monotonically increasing from left to right. Okay, so find the maximum possible sum of the beauties of the remaining flowers. Okay, so question is pretty straightforward. And yes, see here, height of the trees or height of the flowers are up to n. Okay, so let's take a look at this sample test case. Yes, so suppose what uh, what are the sequences of the heights that I can maintain. So I can maintain just 3, so which is at the first index. Here you can see I can maintain 3, then I can maintain 3 4. 4 is at you can say this third index. Then I can maintain 1, I can maintain 1 2, I can maintain 4, and I can maintain 2. Okay, so these are possible 6, these are possible 6 outcomes of Taro's action, right? So this basically fits our constraint that their heights should be increasing. Okay, uh, it is not non-decreasing. Okay, it is not non-decreasing because all the heights are distinct. Okay, so that's strictly increasing. So here uh, his score, or what you can say, the sum of the beauty of the flowers will be 10. Here it will be 10 plus 30 because this 30 corresponds to 4, so it will be 40. What about this one? It will be 20. This 1 and 2, it will be 20 plus 40, so 60. For just the 4 it will be 30, and 2 it will be 40. Okay, so across all of these outcomes I know my answer is this, right? So my answer is going to be 60. Okay, so that's basically how it is, how our solution is going to look. Okay, wait. Okay, it's again, it is copied, no problem. So yes, so to design a solution, I can say that suppose I am at the ith index. Let's generalize. Okay, let's generalize our answer or the solution. Suppose I am at ith index, I am traveling from left to right. Okay, so if I want to take this flower on the ith index, okay, if I want to keep it in the sequence, suppose I keep it, ith flower is there. Okay, so uh, what else? So suppose in that sequence the flower which is at the jth index is also present. Let's say it is present. So if the answer till the here, so till the jth index is suppose answer. Okay, answer of that segment, or you can say sum, not segment, chosen sequence, subsequence, you can say, more formally subsequence. So till here, if its sum is sum and sum till j, then suppose there is this jth index, suppose j1th index, you can say j1th index, there will be j2th index, let's say j3th index, where the height of the flower is less than the height of the flower which is at ith index. Okay, so h j over all j, for all j you can say, okay wait, for all j, hj is going to be, okay, not yes, hj is going to be the less than h of I. Okay, this is the constraint. So if I am taking this ith flower, then suppose it is sum of J2, this is sum till J3. So can I say my sum will be after taking the flower of that ith index, if I want to maximize my answer till the ith index. Okay, till the ith index, I am not considering more than that, I am just considering, I am focused on this ith index. So what will it be? So it will be basically beauty of, okay wait, beauty of ith flower. So basically beauty array is specified as A in the question, so I will take it as A from now on. So A of I plus maximum of all the sum j's, okay, over all j. Do you agree? Do you agree, my friends? So yes, I think you definitely do. So this is basically the thing. So what I can notice here is that I can, if I do it this way, so if I do this way, my solution will be O of n square, right? So basically, when I'm at ith index, I'm checking all the indices less than I, so 0 to I minus 1 you can say. I am checking all the indices 0 to I minus 1, and if the height of the, what you can say, height of the flower at these indices, if it is less than the ith index, then I'm considering it for this maximum calculation, right? So that is basically the thing. So for I is equal to 1, you need to check 0 indices. For I is equal to, okay, let us take 1 based indexing here. So 1 to I minus 1. So for I is equal to 1, you'll end up checking 0. For I is equal to 2, you'll end up checking 1, 1 index here, right? So this is basically the length of this part. So for I is equal to 3, you will end up checking 2. So for all the way up to I is equal to n, you will end up checking n minus 1. So sum of all of these will be n minus 1 into n by 2, which is O of n square, right? O of n square, and our n is pretty large. It's hefty large, I would say, 2 into 10 to the power of 5. So yep, this uh, solution works, but it doesn't fit in our time limit. So how can I optimize this? I want to optimize this solution. So basically this is the whole scenario, right? So I can notice that this is the scenario. I want to find one bottleneck, a bottleneck find a bottleneck to improve this solution to O of n or O of n log n, right? Okay, so what I can see here is that, so here I am taking maximum of all of sum of j's, right? So for this I am taking linear time, right? I am taking linear time. But what about if I need only the logarithmic time? What about that? So then basically my solution would be n log n, which will nicely fit in the constraints of the time limit, isn't it? Yep, and you know, right? Segment tree works well in these cases. Segment trees, tada, again. Segment trees will help us for sure. So let us take a look at the approach from based on the segment trees. So again, I'm going to wait. I'm going to pick this up. Okay. Oh, what? Okay, no problem. I have it here. So let us check the approach for the segment tree. Okay. So basically, DP will be needed. Okay. So my DP of I is going to be the uh, answer. Okay, wait, let me formulate it in the right way. Okay, yes, so basically dp of I is the answer when, okay, so dp of I is basically the answer when your your subsequence is ending at height I, ending at height I. Okay, okay, ending at height I. So basically this is the key point. Okay, so let us visualize it here. So yes, first index. So before that, we will build the segment tree. Okay, we will build the segment tree initially. So there are 4 nodes, so my segment tree will be looking like, okay, today we need the small nodes. Okay, last time we had pretty big nodes while we were solving the question related to the segment tree from div recent div division 2 contest. It was the fourth problem, D problem. Pretty nice problem. I will leave the link in the description for that problem. I think I've really explained it well. Okay, so yep. Okay, it doesn't look skewed. Okay, nice. So basically we will build the segment tree before 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 even checking the first index. Okay, before even checking this 3, we will build the segment tree. So let's start. So before that, segment tree will be 0. Everything will be 0 here. So why I'm saying that is that I'm building this segment tree. So listen carefully. Listen carefully. So I'm building this segment tree for DP array. I'm building this segment tree for the DP array. Listen carefully. So basically it will store DP of 1. Here it is 0 based indexing for DP array, and we will use 0 based indexing for the segment tree. Okay, so here it is DP of 2, here it is DP of 3, here it is DP of 4. Okay, so uh, so dp of I is represented as answer when your subsequence is ending at height I. Okay, so basically everything is 0 initially. Okay, so when I head to 3, okay, when I am heading to 3, so basically my dp of 3 will be updated as 10, right? So yep, let's go and update it. Then here it will be 10 and here it will be 10. Okay, nice. Next thing, so dp of 3 is going to be 10. Now dp of 1, we have to update dp of 1, right? So dp of 1 is going to be not exact, okay, dp of 1, right? So dp of 1 is going to be the a of 1 So beauty of the first flower plus maximum of, okay, maximum of all the dp's, okay, all the dp's starting from 1 to that index I. Okay, here I is just the 1, and okay, so 1 to I minus 1, right? 1 to I minus 1, how can I forget that? 1 to I minus 1. Okay, so that is basically the thing, and we will update this segment tree based on the uh, what you can say, the beauty values, right? Beauty values. Okay, yep. And so we are at second index now, so we have to update the dp of 1, or you can say not exactly dp of 1. Dp of 1 will be this, and we have to update this node, okay, this node with the 20, right? So this node here we have to update with 20 right now, so let's do it without a further ado. So 20, so here it will be 20, updated to 20, so here it will be updated to 20, right? Nice. So yes, and next thing, so for this 4 we have to update this node as 30, so this node as 30, it will be 30, and this will also be 30 after updating. Okay, so yes, and after this fourth index, okay, so let's concurrently calculate dp values as well. So dp of 2 will be a of 2 plus minimum of dp of 1, right? So basically uh, dp of 1, so not exactly dp of 2, right? So we have to update uh, as we go along, right? So we will first update dp of 3, then update dp of 1, then update dp of 4, and then update dp of 2. Okay, so that is basically the thing, and I think you have the idea, right? So how to proceed. So dp of 1 is going to be this, and wait, oh, okay, sorry for the disturbance. So yes, we have to calculate the values of the dp's index by index, so going from first index, then second, then third, then fourth. One more thing is that, so what you must notice here is that, so you must notice, okay, so our array is like 3 1 4 2. Okay, so 10, 20, 30, and 40. So at the end of the process, okay, n is equal to 4. At the end of the process, my dp of 2, my dp of 2 is gonna hold 60, right? So answer when your subsequence is ending at height I. Okay, so yes, we have seen it here, right? So if it is ending at 2, so maximum is 60, so that is basically the thing, and it is going to be 60, right? So when you are calculating the dp of 4, listen this carefully, when you are calculating the dp of 4, you will be like, okay, let me take this a of 3. Okay, why a of 3? Because it is a third index and this 4 is also a third index. So let me take a of 3 plus minimum of all the dp of 1 comma 2 comma 3. Okay, okay, not minimum. Okay, what am I doing? Maximum, right? So maximum. So here you can notice that uh, you will say that dp of 2 will be maximum, then it will be 60, and then 60 plus this a of 3, 90, 60 plus 30, 90. So 90 would be answer, but it is not the case, right? So what you are missing here is that to uh, when dp of 2 is going to be the 60, it is going to be 60 after dp of 4 is calculated. Okay, after dp of 4 is calculated, it is not going to be updated before dp of 4 is calculated. That's the key point. Okay, so when you are calculating dp of 4, my dp of 2 will still be 0. My dp of 2 will still be 0. And uh, basically that's the thing. So there should be no confusion while calculating dp of 4. Okay, so that's basically the thing. And let us directly head towards the code to see how the things are working. So basically, where is the expand button? Yes. Okay, so yes, this is just the segment tree template. Okay, this till here. Okay, this is segment tree class, and it is basically the segment tree template for getting the maximum of the things. And yes, inputting the h, heights array, the values array, the beauty array, and firstly building it according to the dp. Okay, so segment tree nodes are all 0 initially, right? As we have discussed, and we will calculate it for the first index. Okay, we will calculate it for the first index, as there won't be any indices left to that. Okay, so dp of h of 0 is going to be the a of 0. And one more thing is to notice here is that, so we have taken the advantage of this fact, right? So uh, heights are basically up to the n. So we have definitely taken the advantage of that. So dp of h of 0 is 0 because h of 0 is going max up to the n, right? So if it was like 10 to the power of 9, then dp of 10 to the power of 9 doesn't make sense, right? So we have to do some type of hashing to to access the elements, or whatever it is. But yes, it is nice that it is up to n. Okay, so basically updating it to the a of 0, segment 3 dot update. Now one more thing is to notice here is that, so my dp of 1 is stored here. Okay, my dp of 2 is stored here. Okay, what I'm trying to say is that, what I'm trying to emphasize on it as, so segment tree is following zero based indexing. Okay, segment tree is following zero based indexing, and our dp array, or the values which are incorporated right here, are following the one based indexing, right? So that is basically the thing, and that's why here it is h of 0 minus 1. So basically that's index. Okay, so it is ll of I, so lli, long of I, which is the index, and finally updating it with the value. So yes, and similar thing in this for loop as well, basically these three things only. And yes, maintaining the answer as a of 0, not maintaining, initializing it to the a of 0, because you can always pick the first flower. And uh, after all the updates are complete and all the dp array is nicely constructed, we will finally do answer is equal to max of answer comma dp of I. So I is basically the height. Okay, so dp of I, and don't forget what the dp of I means. So that is basically answer, the maximum answer when your subsequence is ending at height I. Okay, so you could have taken the maximum of all the dp of I over all I, that is also fine. Yes, so yes, finally outputting the answer. That is basically it. And yes, see, it has passed nicely. So okay, I hope you enjoyed solving this problem on your own and listening to the solution as well. And thank you for watching the video, and consider liking the video if you found it insightful, and consider staying subscribed, staying tuned to the channel. And I will I will leave the link for the problem which involves the segment tree from the recent division 2, okay, division 1 plus 2, or basically hello 2025 contest. So it was open for all, it was code forces contest. And I will also leave the video solution for that on the end screen right here. So yes, thank you for watching, thank you for watching again. See you again on the channel, surely.